this question we are asked to solve this differential equation. And so we're going to apply the technique of separation of variables. And the first step will be to rewrite y prime as dy dx. dy dx is 5y minus 6. And what we're going to do at this point is put all the y's on the left and all the x's on the right by bringing the dx up to the right and the 5y minus 6 down to the left. dy over 5y minus 6 is dx. And then we integrate both sides. Because we've separated the variables, this only has y, and that makes sense. This only has x's, and that makes sense. So let's think about each of those things separately. Integral of dy over 5y minus 6. That should remind you of just 1 over y. Right? The constants are not going to play too much of a role, but if this were just dy over y, it would be ln of y. So I'd like to say, is this just ln of absolute value of 5y minus 6? If I took the derivative of this, I would get 1 over 5y minus 6, but then multiplied by an extra 5 from the chain rule. So this is not quite right because I get an extra 5 from the chain rule. So what we need to do is undo the extra 5 that would come from the chain rule by dividing by 5. So that if I now take the derivative of this, the 1/5 out front, let's write it out front to keep that separated. The 1/5 out front goes along, the derivative of this is now 1 over 5y minus 6 times 5. And the 5 and the 1/5 would cancel, giving me 5y minus 6. So this one is 1/5 ln absolute value of 5y minus 6. Remember that that only works because that's a linear factor. If that were anything else, if it were x squared or anything else, we'd have to do something different. Integral of dx is just x plus c. So we're going to go further. We're going to be able to solve for y here. We'd like to say y equals is our solution, but so far so good. We've got all the y's on the left, all the x's on the right. So let me save what we've got, and we're going to do some algebra to make it look nicer. 1/5 ln 5y minus 6 is x plus c. The first thing that we're going to do is multiply through both sides by 5. ln absolute value of 5y minus 6 is 5x plus 5c. Now here's the thing. Right? This constant is the constant of integration, and it could be any possible real number. If I multiply it by 5, I still get any possible real number. So really, this is just some other constant. If we want to be technically correct, I would have to call this C1 and this C2, because this one is 5 times before, but by the time we get to the end, we just want some constant in the right place. And so by multiplying the constant of integration by something, it doesn't change the fact that it's any possible number. Same thing happens right here. Now, ln of something, ln of y equals x, so this is e to that. We want to transfer this over to exponentials. This is e to the right-hand side is what's inside. Absolute value of 5y minus 6 is e to the 5x plus c. Now we have to do something similar here. This is e to the 5x times e to the c. Right, I can break that apart. If c is any possible constant, then e to the c is any possible positive constant. There's some subtle details that are happening here. This can be any positive number, but the fact that this is an absolute value actually takes that away. You don't have to reproduce all of these subtle details, but what's really happening at this step is that I can remove the absolute value. By doing so, that puts a plus or minus on the right-hand side, which allows the e to the c, since e to the c is any positive number, e to anything is a positive, by putting a plus or minus, it gives me any number at all, any number. So I can really write that as just c e to the 5x. Again, that's not the same c that we have here, and it's just not the same c as we have here. It's not the same c as we have here, but we just need a placeholder for the constant that is in the correct place. Finally, 5y is 6 plus c e to the 5x, so that y is equal to 6 over 5 plus c. Again, it's really c over 5, and this is the last time that we'll have to do it, but c over 5 is just some constant, and the constant can be anything that we need it to be. Finally, let's check our answer in the original differential equation to make sure that it works. Y prime is, the 6 over 5 goes away, c is just c, e to the 5x will be times 5 e to the 5x, so that's y prime. So we get 5c e to the 5x. If I say, what is 5y minus 6? 5y minus 6 is 5 times 6 over 5 plus c e to the 5x minus 6. The 5 in here becomes 5 over 5 cancels and I get 6. I get 5c e to the 5x minus 6. 6 minus 6 goes away and I get 5c e to the 5x. So y prime is 5c e to the 5x. The right hand side is 5c e to the 5x. So yes, it works.